Hi students, I am Prashant Assistant Professor, Automobile Engineering Department, SNIT Adur. Welcome to my new video. In this video, the portions to be covered are precision forging, coining, heading, piercing, die design, that is pre-shaping, design features, draft angles, and die materials and lubrication. Okay. First of all, precision forging. That is shown in this diagram. Complex shape with great accuracy forgings cannot be obtained in open die forging. That is, by using our open die forging, complex forgings cannot be obtained. Okay, with great accuracy. The complex forging can be made in impression die forging, which make use of cavities in special prepared dies to produce forged shapes in large quantities. The finished forgings are duplicates of each other. Since the die is not fully closed, it is called as impression die. Closed die forging are of three types, that is drop forging, press forging, and upset machine or upset machine forging. Okay, this diagram, the workpiece is held in between two dies, that is a lower die and upper die, and impressions are there in both the dies. Okay, then coining. Coining is the process of making coins by placing a workpiece in between two dies and applying compressive force through these dies into the workpiece. Here the compression, here the impression on the die is made on both sides of the coin. Its applications are jewelry making and currency coin making, etc. Next one is heading. This is a diagram. Heading or upset or forging consists of applying lengthwise pressure to a hot bar held between grooved dies to enlarge a section or sections. Piercing can also be done by machine forging method. In this method, the metal is displaced from the interior and made to flow around the outside for the full length of the blank when necessary. Mostly a throw bore is drilled longitudinally through the die for feeding of bar stock. Okay. Heading is mostly used to make heads in balls, studs, etc. Okay. Next one is piercing. Piercing and punching are both similar operations. Punching is the process of producing holes generally by using a hot punch over the hole of the anvil over a cylindrical die or over a hole of correct size in the swage block. Okay, but piercing means the punch will extrude the workpiece to a longer period and longer to a longer space, and actually there will be no hole producing in the piercing process. Okay, there is a difference between a punching and a piercing process. Then die design. Factors which call for proper design of die include draft angles, fillets, corners, shrinkages, cavities, and dimensional tolerances. First of all, draft angles. Draft angle must be provided on the die wall to facilitate removal of the forging from dies. That is, to get the forging out of the die, this draft angle must be provided. Drop forging have 3 to 10 degree draft angle and press forging have 1 to 5 degree draft angle. During cooling, the forging shrinks both radially and longitudinally. So the internal draft angles are made larger than external ones. Internal angles are about 7 to 10 degrees and external angles are about 3 to 5 degree. Okay. Then the design features. This is a diagram. This diagram we can see the flash gutter, parting line, external and internal draft angles, rib, web, fillet, corner, trim line, etc. These are all the design features that a forging die must have. The terminology for forging die is shown in the diagram, and the significance of various features is described below. Some of these considerations are similar to those for casting. For most forgings, the parting line is usually at the largest cross section of the part. For simple symmetrical shapes, parting line is normally a straight line at the center for the forging, but more complex shapes, the line may not lie in a single plane. The dies are then designed in properly. Then next one is pre-shaping. In a properly pre-shaped workpiece, the material should not flow easily into the flash. Flash means the extra workpiece, which is coming out from the die. And the grain flow pattern should be favorable, and the excessive sliding at the workpiece die interfaces should be minimized in order to reduce wear and tear. Selection of shapes requires considerable experience and involves calculations of cross-sectional area at each location in the forging. Computer-aided design, that is CAD techniques, have been developed to expedite these calculations as well as to predict the material flow pattern in the die cavity and to predict the formation of defects. Because the material undergoes different degrees of deformation in various places of the die cavity, the mechanical properties depend upon the particular location in the forging. Next one is die materials. Most of the forging operations are carried out at elevated temperatures. Therefore, the general requirements for die materials are: first one, strength and toughness at elevated temperatures, hardenability and ability to harden uniformly, resistance to mechanical and thermal shock, wear resistance because of the presence of scale in hot forging, and the selection of proper die material depends upon the following factors. First one is die size, composition and properties of the workpiece, complexity of the work shape, forging temperature, cost of the die materials, number of forging required, heat transfer from the workpiece to the dies, etc. Common die materials: tool steels and die steels containing chromium, nickel, molybdenum and vanadium are the commonly used die materials. Dies are made from die blocks which themselves are forged from casting and then machined and finished to the desired shape and surface finish. Next one is die lubrication. Lubricants generally greatly influence friction and wear. Consequently, they affect the force required and the flow of the metal in die cavities. They act as thermal barrier between the hot workpiece and relatively cool dies, slowing the rate of cooling at the workpiece and improving metal flow. Another important function of the lubricant is to serve as a parting agent, that is one which inhibits the forging from sticking to the dies and helps in its release from the die. Okay. Thank you for watching this video. Regarding this video, the very important topics are precision forging, coining, piercing, die design parameters, die materials and lubrication. Okay. These topics are asked for university question for a number of times, and please make sure that you study all these. Okay. Thank you for watching this video. Have a nice day.